This task is going to be, this is a guided walkthrough of the task 9 day 3 activity over at tryhackme.com, and you can access it from here. Just click on task 9, and then we're going to, well, I'm going to read out everything that's going on just so that we can have a little bit of a better understanding as to how to solve the task. So there's a bit of a storyline going on with these tasks, but I'll do my best to put on a dramatic flair for this. So it says, today's AOC challenge follows a rather unfortunate series of events for the glitch. Here's a little passage which sets the scene for today's task. So late one Christmas evening, the glitch had a feeling, something forgotten as he stared at the ceiling. He got up out of bed and decided to check a note on his wall. 2 days in snow sec. With a click and a type, he got his hotel and tickets and sank off to sleep to the sound of some crickets. Luggage in hand, he had arrived at Frosty Pines. To get to the conference, just follow the signs. Just as he was ready, the glitch got a fright, an RCE vulnerability on the website. He exploited it quick and made a report, but before he could send, arrived his transport. In the Frosty Pines SOC, they saw an alert. This looked quite bad. They called an expert. The request came from a room, but they couldn't tell which. The log saved the day. It was the room of the glitch. Okay, so what are we doing in this task? In this task, we will cover how the SOC team and their expert were able to find out what happened, Operation Blue, and how the glitch was able to gain access to the website in the first place, Operation Red. Let's get started, shall we? Alright, so what are today's learning objectives? First, we're going to learn about log analysis and tools like ELK. We're going to learn about ELK, about KQL, and how it can be used to investigate logs using ELK. And we're going to learn about RCE, remote code execution, and how this can be done via insecure file upload. So here we're going to be connecting to our machine. We've got a green button over here that we need to press to start our machine associated with today's task. And we also have to start the attack box today in order to interact with the machine that we just started. So we're going to go up to the top of the screen, and then we're going to click on this Start Attack Box button over here. After that, we're going to see our screen split into 2 panes, with the attack box initializing in the right-hand portion of the web browser pane. So we're just going to wait for this to initialize, but in the meantime, what we're going to be doing is we're going to be reading about what we're going to be doing today. So this is task 9, day 3. Let's go through some of the details. Okay, so we're talking about Operation Blue. In this section of the lesson, we will take a look at what tools and knowledge is required for the blue segment. That is the investigation of the attack itself using tools which enable us to analyze the logs. For the first part of Operation Blue, we will demonstrate how to use ELK to analyze the logs of the demonstration web app, Wareville Rails. Feel free to follow along for practice. Log analysis and introducing ELK. Log analysis is crucial to blue teaming work, as you have likely discovered through this year's Advent of Cyber. Analyzing logs can quickly become overwhelming, especially if you have multiple devices and services. ELK, or Elasticsearch Logstash in Kibana, combine data analytics and processing tools to make analyzing logs much more manageable. ELK forms a dedicated stack that can aggregate logs from multiple sources into one central place. Explaining how ELK collates and processes these logs is out of scope of today's task. However, if you want to learn more, you can check out Investigating with ELK 101 room over here. For now, it's important to note that multiple processes behind the scenes achieve this. In the first part of today's task is to investigate the attack on Frosty Pine Resorts hotel management system to see what it looks like to a blue teamer. You will then test your web app skills by recreating the attack. So we're talking about using ELK. Upon loading the URL over here, within your attack box's browser, you'll be greeted with the ELK homepage. So let's do that. So over at the attack box over here, we're going to click into the terminal and hit enter to dismiss this terminal screen. And then we're going to start up the attack box's browser. So the attack box browser is Firefox. We can access it with this button over here or this button over here. So let's try hitting this button over here to start up the browser. So it says, for today's task, we will use Kibana's Discover interface to review Apache 2 logs. To access this, simply click on the three lines located at the top left of the page to open out the slide-out tray. Under the Analytics heading, click on Discover. So what we need to do is we need to copy this URL here, and then go over to the browser tab over to the attack box browser, click into it, to make sure everything is highlighted here, then use the paste shortcut to paste in. Oh, it looks like we can't paste in directly. Okay, that means what we're going to do is we're going to use this button over here to open up the control bar, and inside the control bar we can click on the clipboard here. After that, we're going to highlight everything in the clipboard and then paste over it. Okay, looks like we have to copy this link and then paste over. Okay, so this is the IP address of the virtual machine that we need to interact with, and the target port as well. Okay, after we've pasted this in, we're going to click on this button over here to hide the control bar, and then in the web browser, in the attack box over here, we're going to paste in the IP address and port and hit enter, and that's going to load up Elastic. So Elastic is just going to take a few minutes, a couple of moments to load, and it's going to say that configuration missing, there's some sort of warning. We're just going to get out of this, okay? And then what we're going to do is we're going to use Kibana's Discover interface to review the logs. So there's this button over here, which looks like three lines. We're going to click on that, and then we're going to click on the Discover button over here. And that's going to bring up our logs. So it says here, under the Analytics heading, click on Discover. We just did that. And it says, we will need to select the collection that is relevant to us. A collection is a group of logs. For this stage of Operation Blue, we will be reviewing the logs present within the Wareville Rails collection. To select this collection, click on the drop-down on the left of the display. Okay, so we need to select Wareville Rails over here. So in here, I think we can click on this button over here, this gray one, and we can select Wareville Rails from this menu. Okay? And the reason we don't see anything is because we haven't selected a time frame. So the next thing we're going to do is select a time frame. Once you've done this, you will be greeted with the screen saying no results match your search criteria. This is because no logs have been ingested within the last 15 minutes. Do not panic. We will discuss how to change this shortly. So to change the date and time, click the text located to the right of the box that has the calendar icon. Select Absolute from the dropdown, where you can now select the start date and time. Next, click on the text on the right side of the arrow 2, and repeat this process for the end date and time. So we need to select a start date and time and an end date and time for the logs. So for the Wareville Rails collection, we will need to set the start time to October 1st, 2024, the beginning of the day, and the end time to October 1st, 23:30, which is 11:30 p.m. All right, so let's do that. So over here, inside the calendar box over here, we're going to select the start. So the start is this portion and the end is this portion. So the start is going to be absolute, so we need to click on this button here. And then we need to select October 1st. So from here, we're going to select October 1st. And we need to select the beginning of the day. So we're going to scroll all the way back in here and select 0000. Okay, so after that's done, we're going to select the end date, which is over here. So click into that, select absolute again, and it's going to be October 1st again. But this time, we're going to go to the end of the day, and the end of the day is going to be 23:30 over here. So just select that. And after that, we can update our logs by clicking on this blue button over here. So go ahead and click on the blue button. And we're going to see that we have 811 hits. Okay. So now that we can see some entries, let's go over the basics of Kibana Discover UI. So we've got a bunch of stuff over here, and so they talk about the search bar where we can place our search queries using KQL. So that is number 1. Number 1 is this section up here, over here, right here, this bar. Okay. Number 2 is index pattern. An index pattern is a collection of logs. This can be from a specific host or, for example, multiple hosts with a similar purpose, such as multiple web servers. In this case, the index pattern is all logs relating to Wareville Rails. So that is section number 2, which is over here. This is section number 2. Okay. So number 3 is fields. This pane shows us the fields that Elasticsearch has parsed from the logs. For example, timestamp, response type, and IP address. That is number 3. So number 3 doesn't appear. This section doesn't appear over here, but it would be over. I do believe it would be here. It's right here. So because we're in this kind of squished view, we can't quite see it. Okay, number 4 is timeline. This visualization displays the event counter over a period of time. So that is section number 4. And section of number 4 is located right over here. So this is the timeline. Okay. Number 5, documents, logs. These entries are the specific entries of the log file. That is section number 5. And I believe section number 5 is right over here. This is the, these are the logs. And number 6 is the time filter. We can use this to narrow down a specific time frame, absolute. Alternatively, we can search for logs based on relativity, for example, the last 7 days. So that is section number 6, and section number 6 is located up over here. This is the time log over here. Okay, so let's move on to the KQL, or Kibana Query Language. It's an easy-to-use language that can be used to search documents for values. For example, querying if a value within a field exists or matches a value. If you're familiar with Splunk, you may be thinking of SPL, or Search Processing Language. For example, the query to search all documents for an IP address may look like this: IP address 10.10.10.10. So we can actually copy this. So we can do IP.address, and then it's going to be 10.10.10.10. But of course, this doesn't really match anything, but we can hit enter. And it's going to show us that no result matches your search criteria. Okay, that's fine. What we can do is we can delete this and then hit enter again. And then we're going to get all of our results back over here. All right. So alternatively, Kibana also allows using Lucerne Query, an advanced language that supports features such as fuzzy terms, searches for terms that are similar to the one provided, regular expressions, etc. For today's task, you will stick to using KQL, which has been enabled by default. The table below contains a mini cheat sheet for KQL syntax that you may find helpful in today's task. So they've got a bunch of different query terms that we can use, such as strings and wildcards, and we can also use different operators like or, and we can also specify this to look for a specific value. Okay. Next, let's talk about investigating a web attack with ELK. So in our scenario, thanks to our extensive intrusion detecting capabilities, our systems alerted the SOC team to a web shell being uploaded to the Wareville Rails booking platform on October 1st, 2024. Our task is to review the web server logs to determine how the attacker achieved this. If you would like to follow along, ensure that you have Wareville Rails collections selected like so. Okay, so it's Wareville Rails, Wareville Rails. Okay, it looks like we're changing our terms over here. So to investigate this scenario, let's change the time filter to show events for the day of the attack, setting the start date and time to October 1st, and set the end date and time to October 2nd. Okay, so we need to change the time frame. So what we're going to do is we're going to go up and we're going to change the end time frame. So this one over here, we're going to click on it, and then we're going to select October 2nd. So it's going to be October 2nd at the beginning of the day, which is all the way up at the top here. And so we're just going to select that, and then we're going to update with this button over here. Okay, and now we have it looks like it's the same amount of hits. That was unexpected. Okay, but that's fine. All right, so you will see the logs have now populated within the display. Please note that the quantity of hits in the task may differ from the amount in the practical VM. Okay. An incredibly beneficial feature of ELK is that we can filter out noise. A web server, especially a popular one, will likely have a large number of logs from the user traffic completely unrelated to the attack. Using the field panes on the left, we can click on the plus and minus icons next to the field to show that we show only the value or to remove it from the display, respectively. Fun fact, clicking on these filters is actually just applying the relevant KQL syntax. So note that in the GIF below that the logs are being filtered to only show logs containing the IP address 10.13.27.115. Okay, so reducing the count from this many to this many hits. We can combine filtering multiple fields in or out to drill down specifically into the logs. Okay. To remove the applied filters, simply click on the X alongside the filter just below the search bar. Okay. So if we ever have a filter, we can get rid of the filter by clicking on the X. So in this investigation, let's look at the activity of the IP address 10.9.98.230. We can click on the client IP field to see which IPs have the most values. Okay, so inside of Kibana over here, we're going to go up to the top, and we're going to add. So let's see. I think we need to. Oh no, we need to supply some fields. Okay. So click into fields, and in the fields list, we're going to look for client IP. So just click in here, type client, and there's going to be a couple of fields over here. Client IP. Okay, so we can just get rid of this stuff over here. Configuration missing. Okay, so filter by type. You know what? I previously worked with this in the large view, so I'm going to switch out to a large view just because this cramped view is getting in my way. So I'm just going to click on this button right over here, which is called View in Full Screen. So just go ahead and click on that. And this is going to start up the attack box in its own browser tab, which means that we can expand our browser window. So we're just going to maximize this. Okay, so now we can filter by type over here, and we're looking for client IP, which is this button over here. So I'm just going to click on that. It says top 5 values. I think this is the one we're looking for, 10, 13, 27, 115. But let me check for sure. Okay, so we're looking for 10, 9, 98, 20, 30. 10, 9, 98, 20, 30. Okay, let's look for that. 10, 9, 98, 20, 30, this one over here. We're going to filter on this. Okay, so now we've created a filter for this. Great. All right. So what do we need to do next? So using the timeline at the top, we can see a lot of activity from this IP address took place between 11:30 and 11:35. This would be a good place to begin our analysis. Okay, so 11:30 and 11:35. Each log can be extended by using the icon located to the left of the log document. Fortunately, the logs are pretty small in this instance, so we can browse through them to look for anything untoward. Okay, so let's go back. And in here, I think, there are quite a few of these over here. And, so I think 11:30, I think we're supposed to look at 11:30. Right, it says here, took place between 11:30 and 11:35. This would be a good place to begin our analysis. Okay, so over here, so this is 11 and 11:30, right? So let's click over here. Okay. So after some digging, a few logs stand out. Looking at the request field, we can see that a file named shell.php has been accessed, with a few parameters C and D containing commands. These are likely to be command inputs into some sort of web shell. Okay, so we can actually look for documents that contain this shell.php. So now that we have an initial lead, let's use a search query to find all logs that contain shell.php. Using the search bar at the top, the query message shell.php will search for all the entries of shell.php in the message field of the logs. So we can actually copy this. So we're just going to copy message shell.php, then go over to our browser, and here in the search, we can paste in the message. Okay. We cannot paste in the message. Hold on. Okay, so we have to go to the button one more time, and inside the clipboard here, we're going to highlight what's already in the clipboard, paste in our own value. Oh, okay. We're going to copy message.shell.php over here again, and then we're going to go back. And in here, in the clipboard here, we're going to highlight this, paste it in. Okay. We're going to close this out, and then we're going to put this in the search bar over here. So the search bar is located over here. It looks like a diskette. Paste in message shell.php, and what this is going to do is it's going to filter out all the messages that do not have message shell.php. It says no results match your search criteria. Okay. So this should be Wareville Rails, correct? Okay. Oh, maybe it's not in this client IP over here. I'm going to remove this filter by clicking on this button. And okay, so because we've removed the filter, now we can see shell.php in here. Okay, great. So all of these logs have the shell.php inside the message in these logs. All right. Okay. So it says here, Operation Red. In this section, we'll take a look at the red aspect, in other words, the attack itself and how it was carried out. So it says here, why do websites allow file uploads? So file uploads are everywhere on websites, and for good reason. Users need to upload files like profile pictures, invoices, or other documents to update their accounts, send receipts, or submit claims. These features make the user experience smoother and more efficient. But while this is convenient, it also creates a risk if file uploads aren't properly handled. If not properly secured, this feature can open up various vulnerability attackers can exploit. So, file upload vulnerabilities. File upload vulnerabilities occur when a website doesn't properly handle the files that users upload. If the site doesn't check what kind of file is being uploaded, how big it is, or what it contains, it opens the door to all sorts of attacks. For example, RCE. Uploading a script that the server runs gives the attacker control over it. Or XSS. Uploading an HTML file that contains an XSS code which will steal a cookie and send it back to the attacker's server. These can happen if a site doesn't properly secure its file upload functionality. Why unrestricted file uploads are dangerous. Unrestricted file uploads can be particularly dangerous because they allow an attacker to upload any type of file. If the file's contents aren't properly validated to ensure only specific formats, like PNG or JPEG are accepted, an attacker could upload a malicious script, such as a PHP file or an executable, that the server might process and run. This can lead to code execution on the server, allowing attackers to take over the system. Examples of abuse through unrestricted file uploads include uploading a script that the server executes, leading to RCE, uploading a crafted image file that triggers a vulnerability when processed by the server, or uploading a web shell and browsing to it directly using a browser. Usage of weak credentials. One of the easiest ways for attackers to break into systems is through weak or default credentials. This can be an open door for attackers to gain unauthorized access. Default credentials are often found in systems where administrators fail to change initial login details provided during setup. For attackers, trying a few common usernames and passwords can lead to easy access. Below are some examples of weak default credentials that attackers might try. So we've got our usernames and passwords: admin, admin, administrator, administrator, admin at domain name, admin, guest, guest. So these are default credentials and they should be changed as soon as possible. Attackers can use tools or try common credentials manually, which is often all it takes to break into the system. So what is this remote code execution, otherwise known as RCE? Remote code execution happens when an attacker finds a way to run their own code on a system. This is a highly dangerous vulnerability because it can allow the attacker to take control of the system, exfiltrate sensitive data, or compromise other connected systems. And what is a web shell? So a web shell is a script that attackers upload to a vulnerable server, giving them remote control over it. Once a web shell is in place, attackers can run commands, manipulate files, and essentially use the compromised server as their own. They can even use it to launch attacks on other systems. For example, attackers can use a web shell to execute commands on the server, move laterally within the network, or download sensitive data or pivot to other services. A web shell typically gives the attacker a web-based interface to run commands. Still, in some cases, attackers may use a reverse shell to establish a direct connection back to their system, allowing them to control the compromised machine remotely. Once an attacker has this level of access, they might attempt privilege escalation to gain even more control, such as achieving root access or moving deeper into the network. So now that we're familiar with remote code execution vulnerability and how it works, let's take a look at how we would exploit it. Practice makes perfect. To understand how a file upload vulnerability can result in RCE, the best approach is to get some hands-on experience with it. A handy and ethical way to do this is to find and download a reputable open source web application which has this vulnerability built into it. Many open source projects exist in places like GitHub, which can be run in your own environment to experiment and practice. In today's task, we will demonstrate achieving RCE via unrestricted file upload within an open source railway management system, which has this vulnerability built into it. So we're talking about exploiting RCE via file upload. Now we're going to go through how this vulnerability can be exploited. For now, you can just read along, but an opportunity to put this knowledge into practice is coming up. Once an RCE vulnerability has been identified that can be exploited via file upload, we now need to create a malicious file that will allow remote code execution when uploaded. Below is an example PHP file that could be uploaded to exploit this vulnerability. Using your favorite text editor, copy and paste the code below and save it as shell.php. Okay, so we have here a bunch of PHP code. So the PHP code is actually inside of some HTML code. And what we can do is we can copy it, and then we can go over to our attack box. And in the attack box, we're going to minimize our window. And we're going to paste in the code because we need to go over to this button over here and put the code in our clipboard. So in the clipboard, we're going to get rid of what's already there and then paste in the code. And after the code is pasted in, we're going to click on this button to hide the control bar. Then we're going to start up a terminal. So we can access the terminal with this button right here or this button right here. We're just going to use this button at the top. And that's going to open up a terminal window in our attack box. So we're going to make this a little bit bigger so that it's easier to see. And I'm going to create a file called shell.php. And I'm going to use the nano text editor to do that. So it's nano space shell.php and then hit enter. Okay. So inside of this nano text editor here, I'm going to paste in the code that we got from the THM website. And let's see what this is actually doing. So most of the page over here is just a HTML wrapper, which looks like a regular web page. But we have this PHP section over here. And the PHP section is going to allow us to run commands on the system. So this section over here is going to establish a URL parameter, which is called command. So through the command URL parameter, it's going to run this function over here, which is called system. So system is a PHP function which runs OS system commands and then gets the results. And it's going to return them to the web interface through this PHP, through this URL parameter over here called command. So we're going to demonstrate how this works a little later, but we're going to save this file first. Okay, so we're going to save out this file by doing Control-X, save modified buffer, press Y for yes, and then hit enter to save this file as shell.php. So just in case you were wondering, inside of the terminal, we're currently in the root directory. And if we look at the root directory's contents, we'll see that the shell.php file is in here. So we're going to be using this in a little bit, but let's go back to the TryHackMe page. So it says here, okay, so in the above script, when accessed, displays an input field. Whatever is entered in the input field is then run against the underlying operating system using the system PHP function, and the output is displayed to the user. This is the perfect file to upload to a vulnerable rail system reservation application. The vulnerability is surrounding the upload of a new profile image. So to exploit it, we would navigate to the profile picture page, and instead of a new profile picture, we can upload our malicious PHP script and update our profile. So in the case of this application, the RCE is possible through unrestricted file upload. Once this profile picture is uploaded and updated, it is stored in the admin assets image profile directory. This file can then be accessed directly via this file path right here. And when this is accessed, we can then see the malicious code in action. Okay? Now we can run commands directly against the operating system using this bar, and the output will be displayed. For example, running the command pwd now returns the following. Okay? And then we get the present working directory for the application over here. All right, so making the most of it. Once the vulnerability has been exploited, and now you have access to the operating system via web shell, there are many steps you could take depending on A, what your goal is, and B, what misconfigurations are present on the system, which will determine exactly what we can do. Here are some examples of commands you could run once you have gained access and why you might run them. If the system is running on the Linux OS, like our target example system. So here are some different Linux commands that we could run using the web shell to get more information on the target. For example, ls, cat, pwd, who am I, hostname. So we won't go through all of these different commands because there's a lot of them and we'd like to save a bit of time. But if you'd like to take a look at yourself, then you're certainly free to do so. These are just some commands that can be run following a successful RCE exploit. It's very open-ended, and what you can do will rely on your abilities to inspect an environment and vulnerabilities in the system itself. So let's move on to our practical challenge of the day. Your task today is twofold. First, you must access Kibana on this port over here to investigate the attack and answer the blue questions below. Then you will proceed to the Frosty Pines Resorts website at this domain over here and recreate the attack to answer the red questions and inform the developers what element of the website was vulnerable. Please note, to access http frostypines.thm, you will need to reference it within your host's file. On the attack box, this can be done by executing the following command in the terminal: echo this IP address here, frostypines.thm, and pipe that and redirect the output to the etc. host file. Okay, so let's do that. So we're just going to copy the command here, copy the complete command, and then we're going to go over to our attack box. In the attack box, we're going to need to open up the clipboard again and paste in the command, and then close the clipboard again. Then inside the terminal here, we can paste in the command, and this is going to add this domain right here, frostypines.thm, and associate it with this IP address in our etc. host file. This is going to let us resolve this, this domain name. So go ahead and hit enter after you've pasted in this command, and then we're going to go back and see what else the TryHackMe page wants us to do. Okay. So what we can do, well actually, first of all, let's do a quick command to make sure that we can communicate with this domain. So we're just going to ping this frostypines.thm domain and make sure that we can contact it. Okay, so we are receiving ping packets back from frostypines.thm, which means that we've successfully added this this entry to our etc. host file. Okay. All right, so let's go back. Okay, to review the logs of the attack on Frosty Pines Resorts, make sure you select the Frosty Pines Resorts collection within ELK, such as the below. So we need to go over to this portion in the Elastic interface and select Frosty Pine Resorts. So let's do that. So over at the attack box, go back to the Firefox web browser, and then this button over here. All right, so what we need to do is we need to change our collection. So we're just going to click on Wareville Rails here, and we're going to select Frosty Pine Resorts instead. So just select that. And what we need to do is we also need to change up our timeline. So what time do they want? So the date and time you will need to use when reviewing the logs is between 11:30 and 12 on October 3rd. Okay, 11:30 and 12. Let's go over here. So October 3rd, the timeline is right here. So we need to change these two timelines. So it's going to be October 3rd, and I think it's 11:30. So we're going to set this to 11:30 and 12. So in this section here, we're going to set October 3rd, and we're going to set this to 12 p.m. And then we're going to click on Update. Okay, so we've got 13 hits. We do not have very many logs to deal with here. Great. Okay, what's next? So remember to access the Frosty Pines Resorts website. You will need to reference it in your host file. On the attack box, you can do this by using this command. So we've already done this, and we're going to answer these questions right here. So the blue question here is, where was the web shell uploaded to? So we're going to look for a directory, so 3 different directories, and then file name.php. So we know that the web shell has the name shell.php, so we can actually search for that. All right, so we're going to go back here, and we're going to search for message shell.php. I think this has already been applied. Okay, that's great. So we're looking for the file path. So inside the logs here, we see that the file path is media image rooms shell.php. So this is the answer we're looking for. So can we copy this? So I'm going to try to copy this, and then I'm going to look at my clipboard. Yeah, so in the clipboard here, we're going to need to copy this in order to put it on the website. So we're just going to copy this over here, media image rooms shell.php. We're going to close the clipboard. We're going to go back to the THM website, and we're going to paste in the answer and then click on submit. Okay, your answer is correct. And the last question for the blue section is, what IP address accessed the web shell? What IP address accessed the web shell? All right, so let's take a look. Let's go back and let's take a look at the IP addresses. So I think what we can do is inside the field names here, in the field names, there's the client IP. So we're just going to click on client IP. Actually, no. We're going to press this plus button here on client IP to add the field as a column. Okay, so we only have 2 options here. We've got this IP address right here, but we have a bunch of different communication with this IP address right here, 10.11.83.34. So if we open up one of these, and we can open up one of these logs by clicking on this button here, the arrow button, we can see here that there are commands over here in the web shell provided via the command URL parameter. So we've got ls, this is a Linux command, and we also have echo glitch.txt. So this is obviously the user that is accessing the web shell. So we know that the client IP is 10.11.83.34, 10.11.83.34. So let's 10.11.83.34. And we're going to provide this as the answer. We're going to click on submit, and that is correct. That is the correct answer. Okay. All right. So we have one task from the red portion over here. What is the contents of the flag.txt file? All right. So in order to do this, we need to recreate the attack. And to recreate the attack, we need to visit the frostypines.thm website. So over in our attack box, we're going to create another tab. We're going to upload a web shell and get a flag. So we need to go to http frostypines.thm. Okay, and so we've got this interface here, and so we've got a bit of a cheat code because we can actually go back to the logs over here, and we can see where the web shell was uploaded to. So the shell was uploaded to media image rooms shell.php on the Frosty Pines website. But I think what we need to do is we need to find some way to upload a file because we're talking about malicious file upload. So let's go back. So over here, we've got our account, and I think we're going to try to log in. So we're trying to log in. Previously, they were talking about default credentials. So if we go over here and we search back up to the default credentials they were talking about over here, usage of weak credentials. So we've got admin, we've got administrator admin, we've got admin at domain name, and I think this is what they're looking for in this case. So admin at domain name, I think that's the format we're looking at. So over here, so enter your email. You have to log into an account, you have to enter an email address and a password. So it's going to be admin at the domain. So the domain in this case is frostypines.thm. So it's going to be admin at frostypines.thm. And the password is going to be admin. And then we're going to click on login. Okay, and we're now logged into the website as the admin user. Okay, so next, what we're going to do is we're going to try to use some admin features on this website. So admin, okay, so we're logged in as the admin. So let's take a look at the rooms over here. Okay, so we've got some rooms. And I think what we need to do is we need to access the admin panel. So on a lot of websites, the admin panel is accessed from the admin endpoint. So I'm going to go over to not index.html. We're going to go to the admin directory by, okay, file not found. So where is the, let me go back. Oh, you know what? The reason why that didn't work was because I was using the wrong address bar. Okay, so I was using my actual web browser web bar address bar instead of the one inside the browser. So inside the attack box. So the one inside the attack box, it's important to get that right. There's this URL bar, and then there's this URL bar, which is for the attack box. Okay, so inside of here, frostypines.thm, I'm going to go to the admin endpoint there. And this is the admin endpoint that lets us do some admin actions. I think we can, so what we can do here is we can add a new room. So we're just going to use this function, and it lets us add rooms to the reservation application over here. So the room name over here, we're going to set this to HackerFrogs, like and subscribe. Okay, and we're going to add a image to the room as well. So this is where the unrestricted file upload vulnerability exists, because we can upload a file for the with the room when we're creating a new room. In this case, what we're going to do is we're going to go to the root directory, and then we're going to go to other locations, computer, and then we're going to go to the root directory here. And inside the root directory, we're going to select all files. So here we have to select all files. So we now have the shell.php file over here that we created earlier. We're going to click on it. We're going to select open, and then we're going to add the room. So we go ahead and do that. And then we see here our new room that we added here, HackerFrogs Like and Subscribe. So in the under the picture here, it's blank. So where is this? Well, we could easily find out by right-clicking on one of these other pictures and selecting Open Image in New Tab. So if we open this image in a new tab, we see the file path where all the files are. So rooms, media image rooms 4.jpg. What we want to do is we want to access the web shell that we created on the system. So it's going to be shell.php, and then we're going to supply a URL parameter. So it's going to be question mark, and then it's going to be command equals something. So in this case, I'm going to do ID, so I can see actually, I'm going to do who am I to see what user I'm running as. So hit enter. We're going to see www data, okay? And we also have this convenient little box over here that we can use to execute our commands. So we're going to use the ls command to see what's in this directory right here. So type in ls, hit execute, and there are a bunch of picture files over here that are labeled 1, 2, 3, 4, 5, 6. There's also our shell.php file that we uploaded right now, and there's the flag file over here that we need to read to complete the challenge. So to complete the challenge, we need to execute the command cat space flag.txt. So after we do that, click on execute, and then we see the flag that we're supposed to submit over here. Glitch, THM glitch was here, so highlight that, copy it, and then go over to this control panel here, click on the clipboard, and then from here, highlight the text glitch was here, copy it, then close the clipboard, go back to the TryHackMe page, navigate all the way down, and then under this question here, what are the contents of flag.txt? Paste in the answer, click on submit, and then to complete the room, we need to click on this last question right here. So if you like today's task, you can learn how to harness the power of advanced ELK queries. That's great. You can investigate that room if you like, but we're going to finish this task by clicking on this button over here. And now we've finished the room. Awesome. All right, so thank you very much for watching today's video walkthrough of day 3 of the TryHackMe Advent of Cyber event. We're going to be back with more videos, but until then, we'll see you next time.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.